Now let's look at partitional clustering. Partitional clustering is a non-hierarchical clustering wherein you will have to mention the number of clusters that you want, and these clusters would be non-overlapping. Now k-means uses predefined number of clusters. A particular object would be assigned to either one cluster or the second cluster. It is mutually exclusive. The clusters are of spherical shaped and they are based on distance. The cluster centers would be the mean or median of the objects associated in that cluster. These methods are generally less computationally intensive and are therefore preferred if you are having large data sets. In k-means, we generally do the division of each object into non-overlapping clusters. Unlike hierarchical clustering, where a set of nested clusters are formed and which can be organized as a tree. In k-means, since one starts with a random choice of cluster, the result may be different while running the algorithm various times. But hierarchical clustering results are reproducible. The figure over here shows k-means clustering, and this is hierarchical clustering. Here you can see that clusters are mutually exclusive. In hierarchical clustering, the clusters are actually nested. We have a smaller cluster and a larger cluster and a larger cluster. The hierarchical methods are especially used when the goal is to arrange the clusters in a natural hierarchy. The generated tree may correspond to a meaningful taxonomy. So these are the steps for k-means clustering. First, we have to decide on the value of k. Initial k cluster centers are randomly decided. Then decide the class membership of the n objects by assigning them to the nearest cluster center. Whatever cluster centers that you have decided, the objects near to it are assigned to that cluster. Then again, what are we going to do is re-estimate the k cluster centers. The cluster centers would be adjusted by assuming the membership found above are correct. And if none of the k objects arranged membership in the last iteration change the membership in the last iteration, then you exit. Otherwise, you again go to the step 3, decide on the class membership of the n objects by assigning them to the nearest cluster center. Now, suppose we are having these various records and now we want to cluster them up. So we may decide on having the k values. The k value is 3 over here, so we are wanting 3 clusters. So now you may decide whichever cluster is near to a particular centroid, we'll just move that point to that particular cluster belonging to that particular centroid. Now we can see that we have grouped all the points into 3 depending upon the distance. Now we will have to readjust the centroids. After we have readjusted the centroids, again we will be assigning the numbers to the centroids. Now this is a red colored, this point is in the red colored group. Now you can see that centroids keep readjusting and the points also keep readjusting into groups. After repeating these steps, you'll find that the centroids at one point in time will not change. They will become stable. So now you are having your final clusters. Okay, let's see a very simple example. These are the n numbers that have to be clustered into 2 clusters. So initially what we do is we just pick up any 2 random numbers from the list and make them the centroids. So 4 and 12 are the 2 initial centroids for us. Now what you do is pick up a number and see whether it is nearer to this centroid or is it nearer to this centroid. If it is nearer to the first centroid, you put them in the first cluster. If it is nearer to the second centroid, you put them in the second cluster. So you can see that 2 is nearer to 4 because 4 minus 2 is 2. 2 minus 12 is 10. So we are putting 2 in the first cluster. If you see 10, 10 minus 4 is 6. 10 minus 12 is 2. So we are putting 10 in the second cluster out here. So once we have done the first step, we have to readjust the centroids. Now centroids were 4 and 12. The new centroids are 3 and 18. How did we get that? 3 is an average of the numbers in the first cluster. 18 is an average of the numbers in the second cluster. Again we will be repeating, we will be seeing is 2 nearer to 3 or is 2 nearer to 18. If it is nearer to 3, definitely, so it comes in the first cluster. If you pick up 10, 10 minus 3 is 7, 10 minus 18 is 8. So now 10 will go in the first cluster. So you can see that 10 has jumped from the second cluster to the first cluster. Again we got to repeat it. How did we get this? 5 is an average of these numbers. 20 is the average of these numbers. Again we'll be repeating, seeing whether 2 is nearer to 5 or 2 is nearer to 20, and we'll be adjusting the numbers. Now we have readjusted the centroid. Centroid is 7 because it is the average of these numbers. The centroid of the second cluster is 25. It is an average of these numbers. Now again we'll be repeating the same thing, and we see that the points are not jumping into the other cluster, and the centroids now would stabilize. So now you have got your final clusters. So if you visualize the graph, these are the kind of clusters that have been created, and these are the centroids. The centroids are 7 and 25.